Good morning, guys. If we can start with some green check marks, please. Thank you. I gotta say that Mrs. Warden would, just Mrs. Wood this morning, I haven't seen Mrs. Ward yet, but Mrs. Wood came storming into my office this morning telling me how great the field trip was yesterday. She was very excited about it, and she showed me the picture of where she got to sit next to the judge, and she seemed to think that it was really great. So we're always interested in hearing what you guys thought. Maybe just quickly in chat, let us know what you thought. Did you guys have fun? Did you enjoy it? You think it was good? Was it worthwhile? Would you recommend it to other students? You'd like to have gone. Yeah, sorry, Kaylin, you were a city away. It was cool. That's good. I'm glad you guys liked it. That's good. Good, Josh. Yeah. Mrs. Wood, was very happy to see all of you guys out there, with the exception of a few of us who weren't there. A few cities, yeah. So yeah, it was great to have you guys out there. I'm sorry I couldn't have made it yesterday, but I will definitely. We'll look forward to it again. Hopefully we can do it again next year with grade 10s again. Perfect. I just wanted to mention a few things about the course. Reminder, April 20th, which is a Thursday, so that's, what was that, 7, 8, 9 days away. We're going to have our midterm exam here at McWilliams Center at 9 o'clock in the morning. And I didn't check how many questions it was again. I really should make a point of doing that, so I'm not just telling you randomly. But remember, it's mainly multiple choice, a little bit of written from the chemistry unit that we're going through right now. So the midterm exams on chapters 1, 2, and 3, which was the biology unit. Chapter 10, which was earth science, plate tectonics, Pangea sort of stuff. And then we're going to have a little bit of stuff from unit 4. So mainly the stuff we did last day, perhaps a little bit of the stuff we're going to do today. So what I did in the course was I took an old biology review I had, and I just uploaded it. So if you log into the course, you probably saw it already, but if you haven't logged into the course, at the very top of the course I put midterm review. The biology review is an old multiple choice biology test, so it has all 3 chapters of the biology material. I think it's 62 questions long, which is a lot. So don't think that the test is going to be that long. It's just, it's a review of all of biology. So if you would like some extra stuff to look at prior to the midterm, you want to start reviewing, this is a good place to start. Just additional things. I'm not going to collect it. It's just for you studying. If you would like to go through that, that's fine. If you do have questions about it, I'd be happy to answer them in class next day or next Tuesday. And then there was it's called the Module 3 review. It's just on plate tectonics. So remember, plate tectonics was just chapter 10. It was a fairly small unit. So there's not a ton of information there. Just a few matching terms, and then the different symbols, and then the different sorts of plates interactions, and then a little bit of stuff on earthquakes. So does this review cover all of chapter 10? No, but this covers the majority of big concepts from chapter 10. So the majority of the exam, obviously by size, is going to be from biology, because we've done three units of biology. We have the 1 unit of earth science, and then maybe 1 or 2 sections of the Science 10 material, or Science 10 chemistry stuff where we've been looking at in the last couple classes. So that's that. I'll get an exact number of questions for you probably on Thursday's class. Just in general, does anybody have any questions about the midterm exam? Anything they're confused by, don't understand, need help with? Essentially, all you need to do is show up with yourself and a pencil and a calculator. And you probably won't even need the calculator, but if you want a calculator, it's there. How much does it count for our grade? It's a good question. I'm just going to jump into the course outline just so I don't mess it up. What did I say? Midterm exams, 20% of your grade. So all of your unit exams from the 10 chapters are 30%, and then your midterm exam is 20%. So it's a pretty big portion of your grade. How many pages is the chemistry portion? I don't have an exact mark breakdown of the chemistry. I think there's a little bit of written stuff, kind of like Bohr model, and a little bit of naming, which we're going to cover today. But definitely the majority of the test is going to be on the biology stuff that we have been doing, plus some earth science. I will have an exact breakdown for you, Jenna. In class tomorrow, I'll go have a look at it. I wanted to make some adjustments to it, so I haven't quite gotten around to that yet. So I don't have exact numbers of questions, but I will have a fairly good indication of what everything's going to be on it next class. If that works for you, it's definitely worth studying for, but don't beat yourself up over it. It's not going to be like... not going to be the most difficult thing ever, but just what do you know? What do you know about biology? So at the top of the course, those 2 review items. I'm not going to do a review of the chemistry stuff because we've just talked about it, this week. So there's no point in reviewing something you've just learned. And we're just going to continue on today with the section 4.2 stuff. So we've done the atomic theory and bonding. Now we're going to go into names and formulas of compounds. Jenna, for the first part of the test that is not chemistry, what I do just find studying the notes. Yeah, I mean, everything that's on the test is going to be in the notes. So if that's kind of the way you like to review and study, then I don't see any problem with that. But sometimes when you're studying notes, it's kind of one of the things I talk about at the end of the course, and I talked about at the end of our math courses as well, is that a lot of times when students review and study, they focus on things they know, which kind of seems funny, but it feels good to learn or like look at stuff. You're like, oh, I remember this, I remember how to do that. And if you didn't learn something along the way and you don't understand it, you just kind of push it to the side and you're like, well, I'll just look at it later. Really, when you're studying, you should be looking at things you don't know. Those are the things you should be focusing on, things you didn't understand the first time. And that is probably you'll receive the greatest benefit if you start spending time looking at things you didn't get the first go round, even though they may have been hard. It's definitely worthwhile to do that. Okay, so last day we kind of wrapped up the atomic theory and bonding. At the end of class, I was kind of going through Lewis dot diagrams and then bonding, and we just kind of rushed through all that stuff. So what I wanted to do today is I just wanted to start with any questions you guys had out of the learning guide. I gave you, I think it was I don't remember now, a few pages of the learning guide to do. So practice 4.1 atomic theory and bonding. We finished it up, and I just want to see if you guys had any questions in regards to any of this stuff from the learning guide. I was hoping you would have finished it. There's a couple Bohr model questions for atoms and ions. There's a little table, writing in elements, Lewis structures and whatnot, page 12. And then question number 13. So, was there any questions from the section 4.1 kind of problem-y section from the learning guide that you wanted me to go through? I'd be happy to kind of go through anything you wanted there. Yes, good, Costin. Not necessarily page number, but question number, because my pages are likely going to be a bit different than yours. If you want to put in page number, it can kind of get me close, hopefully. Page 14, question number, or just the whole page. This is what my page 14 looks like, which is not the right stuff. So Costa, I'm going to need a question number because mine formatted differently than yours, clearly. Anything for 4.1? You didn't get. Question number 13. That was that bonding one I think I was just looking at. This guy. Draw Lewis structures for an N2 molecule in the ionic compound Na2O. That's the one you're looking at. Clear all this stuff out. The chart. This chart isn't question 13 though, Costin. Number 13 in the chart. Help me out, Costin. You talking 12 or 13? Okay. Here we go. Erase some of this and we can go from there. All right, so this is the chart I believe you're referring to. It says draw Lewis diagrams for the atoms and ions, the first 18 elements. So remember the difference between an atom and an ion is an atom has the same number of protons as electrons. That's what an atom is. But elements don't like having an outer shell that's not full, so they're going to either gain or lose electrons to make their outer shell full, whatever is easier for them. So if you are an atom that has like 1 or 2 electrons in your outer shell, you're going to get rid of them, and you're going to become an ion. If you are an atom that has like 7 electrons in your outer shell, and there's room for 8, you're going to gain 1, and you're going to get a full outer shell. All right, so atomic number of elements. So this is the element number. So the third element on your periodic table, and if you don't have one of these periodic tables next to you, isn't that fun how the green disappears? If you don't have one of these, you need to get a periodic table printed off, preferably the one from the course, because that's the one you're going to use on tests and whatnot. I've got mine here. I'm going to use it extensively for the next few classes, and we're not going to pull up a periodic table every time we need to search for an element anymore. I'm going to assume, which is always a bit of trouble, but I'm going to assume that you have your own periodic table with you. Element number 3 is lithium. Group number is the column it's in. So if I find lithium, element 3 on the periodic table, and I go to the top and I see there's a number 1 there. So lithium's in group number 1. And the Lewis diagram, we start with the elemental symbol in the middle. So lithium's Li. And because lithium's in the first column of the periodic table, it's going to have 1 valence electron. Okay. Now I need to draw the ion of lithium. Now, lithium has 1 electron in its outer shell. Is it going to get rid of that 1, or is it going to gain 7? It's just going to be easier for it to get rid of 1. Finding 7 is going to be tricky. So if we want to draw the ion, I'm going to put in my symbol, lithium. Because it's gaining and losing electrons, or gaining or losing electrons, I'm going to draw square brackets around it. And lithium is going to get rid of an electron. It's going to get rid of a negative charge. So before it had 3 protons and 3 electrons, but now it got rid of an electron. So now it's got 3 positive charges, only 2 negative charges. So overall it's going to have a charge of +1. Now because lithium lost its electron, notice I don't have to draw any dots in for my ion of lithium because there aren't any electrons in its outer shell. It lost it. It has an empty outer shell. The last thing is cation or anion. Didn't spend a lot of time talking about this. It was just kind of a bullet point in the notes. But if you have a positive charge, you become a cation, which means positive. Spell positive correctly. So cation is positive charge, and we'll look at an anion here in a second, which means negative charge. All right, so that's the first one. Let's do number 4 here. Element number 4 on the periodic table is beryllium. It is in the second column, if you go to the top. So it is in group number 2. It is Be, and beryllium, because it's in column number 2, is going to have 2 valence electrons. Now, if I'm beryllium, I want a full outer shell. So I have a choice of trying to gain 6 or lose 2, and it's just going to be easier to lose 2. So if I am beryllium, I will have no electrons in my outer shell. Because I lost 2 electrons, I lost 2 negative charges, I'm going to have a charge of +2. And because I am positively charged, I am a cation. All right. Number 5, boron, and 6, carbon. Things get a little bit tricky with these guys because they aren't going to form ions. They're not going to gain or lose electrons like the metals on the far left or the nonmetals on the far right. Because they have kind of a middle amount of electrons, like carbon has 4 electrons. Is it going to gain 4 or lose 4? Carbon doesn't really generally form ionic compounds. It doesn't gain or lose electrons because it just has those 4. It's more likely to share. So if you look at the periodic table and you see something without a charge next to it, chances are it's not going to form an ion. So if I find boron and carbon and silicon, I keep saying silicon, these guys don't have charges next to them, so they're not going to form ions. Everything else does have a charge next to it. So those are kind of exceptions to the rule, which isn't great. Costin, does that give you a bit of an idea how this is supposed to be done? Let's look at one more. Let's look at number 7. Element 7 on the periodic table is nitrogen. If I find the column it's in column 15. And nitrogen's a little bit different because it is a nonmetal. Because it's element 15, it's unfortunate. Because it's element 15 on the periodic table, it has because it's in column 15, it has 5 valence electrons, or 5 electrons in its outer shell. Why does carbon have electrons around it? Carbon, when we draw a Lewis dot structure, we show the valence electrons. So because carbon's in column 14, we kind of just lose the 1 in the 14 and it has 4 valence electrons. Just like nitrogen's in column 15, and we just kind of ignore the 1 and it has 5 valence electrons. So the third column there, Costin, is asking us to draw the Lewis dot structures for the elements we're dealing with here. So if I'm nitrogen, I have 5 valence electrons. I have to decide if nitrogen's likely to gain 3 to fill its outer shell, or is it going to lose 5. So because nitrogen is a little bit closer, it's a little bit easier to gain electrons. If I'm nitrogen, I'm going to gain electrons. I had these 5. My numbers all mixed up today, which probably isn't helping you guys. So that's what a nitrogen atom looks like. Atom just means the amount of protons and electrons are the same. When I make it into an ion, I need to say, okay, is it going to gain or lose? And in this case, nitrogen is going to gain. So I'm going to draw on those 3 extra electrons. I'm going to draw them in as red, just so you kind of see that those were extras. And then I'm going to put my brackets around it. I'm going to write in my overall charge. So nitrogen, because it gained 3 electrons, and each one of those electrons has a charge of -1, when I draw in the ion Lewis dot diagram, I'm going to draw in the 3 extra electrons, and I'm going to show that it has a charge of -3. So everything in this column here, going up and down, you're either going to have a full shell or you're going to have an empty shell. Those are the only 2 possible things you can show here. So if I'm a metal, you can see up at the top, beryllium, empty shell. It gave away its electrons to form an ion, doesn't have any electrons in its outer shell. When you get down to the metals, because they're gaining electrons, the non-metals are gaining electrons, they're going to have full outer shells. So I think you just do the first, what did we do? First 18. So again, you can see some of the ones that I did last year. Silicon is one of these ones that's kind of in the middle, element 14. It's a bit tricky. It doesn't form an ion because it's going to gain or lose 4. You don't know which way it's going to go. You get into the metal or non-metals down at the bottom, sulfur and chlorine. They're gaining electrons. They're going to have overall charges, just depending on how many electrons they gain, how many electrons they need to fill their outer shell. So chlorine, because it has 7 electrons in its outer shell, it's in column 17. It's going to gain 1. We look at sulfur is in column 16, so it's going to have 6 valence electrons. It's going to gain 2. So that's what those are going to look like. And because they are negatively charged, they are anions. Anions. It's that last column there. All right. Was there any other questions regarding anything in the learning guide from section 4.1? If there's nothing else that you kind of scratching your head about, we're going to move into section 4.2, which could be a good thing for some of us. Kind of make things really easy to start, and then we'll kind of get a little bit trickier as we go. All right, I don't see anybody furiously typing, so we're just going to keep moving. So this is continuing on in the notes. This is section 4.2, names and formulas of compounds. Now, I think it's really, really important to kind of understand the types of compounds. This will make your life a lot easier if you plan on moving forward into chemistry next year, possibly. You know, a lot of the stuff you do in chemistry in grade 11 is based on this section, so really kind of important stuff. I'm going to do my best to break it down into sections. So we're going to talk about simple ionic compounds, we're going to talk about multivalent, we're going to talk about polyatomics. The problem is, I don't know if it's a problem, but when you get to a test or a quiz or you're doing a worksheet or something, generally speaking, a worksheet isn't going to break down the problems into these different types. So we're going to go through the types, and everything's going to be really straightforward and really easy, and I guarantee that, well, I can't guarantee that everybody's going to get it right away, but it's pretty basic to start with. Then we're going to get a little bit more complicated and a little bit more complicated, and then the problem we run into is when we put all the questions together and it's just a mix mash of everything, things get really confusing because you never really know, or I shouldn't say you never really know, but once you can identify them, it'll make it a lot easier. So we'll start as basic as we can. We're going to continue talking about the difference between ionic and covalent compounds. And for today, we're just going to name some ionic compounds, some fairly basic ones. So when we have an ionic compound, remember ionic means ion. That's kind of the base word there. It means your elements are sharing. I'm just terrible today. I think I should just stop talking. I keep saying the wrong things, frustrating myself. Ions are atoms that have a charge. So electrons are being transferred. You can see the little cartoony GIF thing next to me here. The sodium's a metal. It's getting rid of its electron. Fluorine says, I'm a nonmetal. I need 1 electron for my outer shell. I'm going to take that electron. So sodium gets rid of an electron, becomes positively charged. Fluorine gains that electron, becomes negatively charged, and because of their opposite charges, they stick together. So, of course, this is very basic looking at one atom of each of these two elements. But in reality, when you have an ionic compound being formed, it's not going to be one atom stuck together and it's done. It's literally going to be millions and millions and millions, and they're all going to stick together, and they're all going to be arranged in kind of the lattice structure above me, behind my head here. So ionic compounds will form these kind of crystalline structures where instead of it just being two atoms stuck together, there'll be literally thousands of atoms stuck together, and they'll form these kind of lattice structures. So things like, if you can imagine table salt. Table salt is, or sugar is not a good example because it's not ionic, but table salt, if you looked at it under a microscope, it would look like crystals. And salt crystals, you've probably heard about, referred to it that way before. So salt is literally millions and millions and millions of sodium atoms and chlorine atoms bonded together, and they form these kind of lattice structures and crystalline structures. So those are ionic compounds. The example in the notes here is kind of like a stack of bricks, and we use the example of sodium chloride, which is table salt. Then if we look at covalent compounds are sharing electrons. So we have two nonmetals, they're going to share. And when we have two nonmetals coming together and sharing, what's happening is they're actually sharing these electrons, and it's literally just two atoms stuck together, and that's it. There's not thousands and thousands and thousands and millions of them. So this is an example of a covalent bond between two atoms of hydrogen. Hydrogen, in this case, it has one proton, one electron, and they get close to each other, and you can see how those electrons are kind of shared between the two of them. Now the electrons are shown as dots, but remember, in reality, these electrons aren't going to be these points, they're kind of clouds. So the electrons will be kind of buzzing around both protons. I guess the key idea here is that the electrons aren't being transferred from one to the other. One of the hydrogens doesn't say, hey, I want your electron, and steals it. No, they're both being shared, and these guys kind of hang out next to one another. And that is what you are looking at when you're looking at a covalent molecule. So there you go. Ionic electrons transferred, they form charges, the charges stick them together. When we're dealing with covalent, they get close to each other and they share, and the electrons kind of buzz around both of them equally. All right. This is kind of where we get into the meat and potatoes of this section. The most important thing when we make ionic compounds is that the charges have to balance one another out. If we have 5 positive charges, we have to have 5 negative charges. So ionic compounds won't exist when you have different numbers of positives and negatives. And we'll look at that a little bit further here in a second. So the ratio of positive to negatives gives the proper formula, and the ratio is always written in reduced form. All right, so we have lithium and fluorine, magnesium and oxygen, calcium, bromine, scandium, and selenium. Let's look at a couple examples of this stuff. I don't think are in your notes. So I'll just do a bunch of these, and then hopefully you kind of pick it up, and then we'll look at your notes, has a few additional examples. So let's start with lithium and fluorine. I'm going to just jump over to my notebook, is F. So those are the atomic symbols for lithium and fluorine. On the periodic table, lithium is element number 3. It has a little plus sign next to it, so it has a charge of +1. And fluorine has a charge of -1. Now remember where these magical numbers from the periodic table come from. Sometimes students lose sight of the charges in the periodic table. They just think, oh, they're just, somebody put them there, and they kind of just forget how they appeared there, and it's just magic. Oh yeah, lithium's +1 and fluorine's -1. No, remember we drew the Bohr models of these things, or the Lewis diagrams, and lithium, it had 1 electron in its valence shell. It wanted to get rid of it, so it did, so that's why it's positively charged. Fluorine, on the other hand, has that 7 electrons in its outer shell, so it gains 1 to become negatively charged. So that's where those charges come from. They're not just magically pulled out of air. No, it comes from the Bohr diagrams. Bohr dot, Lewis dot, Bohr diagrams. All right, we discussed that the charges must balance out. So if I have lithium has a charge of +1, it's going to combine with fluorine that has a charge of -1. And what's going to happen is they're going to kind of just come next to each other. And I'm going to go lithium, and I'm going to write fluorine right next to it. And because lithium has a charge of +1 and fluorine has a charge of -1, when it forms a compound, I only need one lithium to balance out the charges from one fluorine. So the compound looks like that, LiF. And they're just written right next to each other. I don't need to put any numbers below here. I'm just going to leave it as is for now. And I will show you a couple more examples, and then we'll look at some of the ones from your notes. So I'm just going to jump back to my notes. Look at the next example. Magnesium and oxygen, calcium and bromine. Okay, so magnesium and oxygen. And then the next one was calcium and bromine. All right. So magnesium, find it on the periodic table. I search, I see it's element number 12. And magnesium on the periodic table has a charge of +2. And then oxygen, I searched, and I found it. It's element number 8 and has a charge of -2. All right, so if I am magnesium and I am oxygen, I get close together. I see that magnesium has a charge of +2. Remember that +2 means it got rid of 2 electrons. The oxygen has a charge of -2. That means it gained 2 electrons. These things are oppositely charged, and the charges must balance. So if magnesium is +2, oxygen is -2, +2 and -2 together gives me 0, and that means that they're balanced. So when these guys come together to form a compound, they're just going to be Mg. And then, oh, that's it. That's what your compound is going to look like. Nothing more than that. Calcium and bromine is going to be a little bit trickier. So calcium, I find on the periodic table calcium's number 20, has a charge of +2 right off of the periodic table. Bromine, find that guy as well, is element 35 and it has a charge of -1. So here's where things get slightly trickier. Well, the first two examples we looked at, the positives and negatives just balanced out already. But with this one, things are different. The calcium has +2 charge and the bromine has a -1 charge. So what's going to happen here is something like this. Now, I'm going to draw a little picture and then I'm going to write down the compound. But I know that my charges have to balance out. So what am I going to have to do to balance these out? Well, because calcium has a charge of +2, what's going to happen is I'm going to need, if I just drew one bromine next to it, my charges aren't going to balance. I'm going to have +2 and -1. So my overall charge is going to be +1. And that's not a good thing because it has to balance out. So that can't work. They won't combine like that. So what's going to happen is we're going to need an additional bromine with another charge of -1. And now at this point, my bromines each have a charge of -1. So I have -1 here, and I have -1 here. And to balance it out, I have one calcium with a charge of +2. So if I added or combined all these things together, I get a 0, and she's all balanced out, which is exactly what I wanted to happen. So when I write down the formula for this compound, I'm going to have one calcium, and I'm going to have 2 bromines. But in order to not confuse things, I'm going to have to put down what we call a subscript. So if I put a little 2 next to the bromine, that just reminds me that I'm going to need 2 bromines for every 1 calcium, so they kind of balance out in terms of their charge. I don't want to put the 2 up top because that's where I put my charges, and I don't want to confuse myself any further. For those of you who are sitting there scratching your head at this point, I promise you it'll get easier in a second. All right, there were scandium and selenium. Let's find scandium and selenium. Scandium. Scandium, scandium, scandium. Where are you, scandium? 21, Sc, and a charge of +3. And selenium is Se, and I got to find it, and I know it's a nonmetal, has a charge of -2. It's element number 34. All right, so here's where things get really, really, really tricky. Scandium has a charge of +3. Selenium has a charge of -2. If I have like 2 seleniums, I'm going to have an overall charge of -4, but I only have +3. Can anyone think of a ratio I can combine these 2 things together that my positives are going to balance out my negatives? I can have as many of either element as I want, but I have to have balanced charges. That's the key here. My positives have to equal the negatives. So the idea here is that if I had a selenium and a scandium, this is +3, this is -2, my charges don't balance. If I added another selenium to the other side, -2, I have -2, -2 is -4, and then I have a +3, and together I'd have an overall charge of -1. That's not going to work. So I need to figure out a ratio of these elements, which is going to allow the charges to balance out. Now Leeds is saying if you had 2 scandiums, that's +3, another scandium, +3, and you're telling me I need 3 seleniums. So +3 and +3 is +6. I think you're getting somewhere here, Leeds. So selenium, oh boy. Selenium is -2, another selenium is -2, another selenium is -2. That's -6. You know what that works out, Leeds? Do you want to let us into your thought process on how you came up with that, Leeds? Or are you just smart? Perhaps seen it before? You did it last year. Somebody already taught it to you, which is great. This will be easy for you. All right, so Leeds was right. So when we write down the compound, we have Sc, and then we had Se. So Leeds said we needed 2 scandiums for every 3 seleniums. And that is how we write that in order to balance out the charges. Okay, so that was all kind of a bit confusing. Let's make it all a lot easier. I don't want to call it a trick, but I'm going to call it a trick. All right. So I think this example is in your notes. For example, what is the formula for magnesium phosphide? So the first thing we need to do is find the symbol and charge for each element, and we always write the metal first and then the non-metal second. Metal first, non-metal. Metal first, non-metal. So magnesium, find it. Magnesium's Mg, element 12 on our periodic table, has a charge of +2. Phosphorus. Search, a search, a search. I know it's going to be a non-metal, so it's going to be in kind of that, on this periodic table at least, it's going to be in the kind of the orange section next to the staircase here. Phosphorus' symbol is P and has a charge of -3. So here we go. There's kind of 2 ways to think about it. You can think about it as I just did when I did those other examples. How many of each of these things am I going to need to balance my charges out? That's the first way to do it. The second way to do it is what I like to refer to as the crisscross method. And the crisscross method looks like this. If I have magnesium that has a charge of +2 and I have phosphorus that has a charge of -3, what I can do is I can take the charges from up top and I can cross them from one element to the next and put them down below. So again, the 2 from magnesium is going to come down, and it's going to be next to the phosphorus. And then the 3 from phosphorus is going to come down, and it's going to be next to the magnesium. So they go from superscripts, charges up top, to subscripts, denoting how many elements down below. This is what I like to call the crisscross method. Now, the reason I didn't just start with the crisscross method is because the crisscross method only works about 95% of the time. And there's about 5% of the time where you're going to run into problems. But that's a good way to think about it. The other way, option B, is just thinking, okay, I have this magnesium's +2, phosphorus is -3. I need 3 plus 2's to give me +6, and I need 2 minus 3's to give me -6. And when I have +6, -6, my charges balance out, and Bob's your uncle. All right, so that's magnesium and phosphorus, Mg3P2. Notice when I crisscross my elements or I put the charges down below, I lose the charges. It's no longer +3 and -2. When I put them down below, it's denoting how many atoms of each of those things I have. So I'm not going to write Mg +3 at the bottom and P -2. They're not charges anymore. They're the number of elements that are present. Let's look at this one, calcium and oxygen. Calcium's +2 on the periodic table, oxygen's -2. If I crisscross my charges, I'm going to end up with Ca2O2. Now the problem with crisscrossing your charges here is that it's not going to work out for you, because if calcium is +2 and oxygen is -2, I only need one of each of those things to stick together to balance out my charges. 1 +2 charge and 1 -2 charge sticks together, and I'm done. But if I crisscross my charges, I take the charges from up top and I bring them down below, I'm going to have Ca2O2. And that's a problem. I don't need 2 calciums for all of my 2 oxygens. I only need 1 of each. So just CaO. So the correct answer is CaO. If you just crisscross, you're going to get this guy wrong. So Leeds saw this last year. How many other people have seen this last year, done this? I think they vaguely remember something like this last year. Just let me know. Make my life a little bit easier. Eric, seen it. Leeds, seen it. Anyone else? Help me out. Haven't seen it. Do we have some haven't seen it? This is new, Mr. Borden. Never seen it before. Jenna, new. All right, I can handle that. Connor vaguely recalls doing something like this, and the rest of you asleep at the wheel. All right, maybe let's look at a couple more examples. About 15 minutes left from the notes. Okay. All right. We get into some of the other stuff a little bit trickier here in a second. So this is section 4.2 practice from your learning guide. This is question number 2. I'm going to erase all these. Make our lives a little bit easier, and I'll leave a couple in there. All right. This is the way I'm going to recommend you do all of these questions. I'm going to recommend you write down the metal first, lithium, Li, and then its charge, so +1, and then write the non-metal second, Se, selenium, -2. And then at this point, so I'm looking at the first example here, what you're going to do is, if you like the crisscross method, and I'm going to recommend it because it's really, really easy, you're going to take your positive charges, you're going to bring it down, come on, there we go. You're going to take your positive charge and you're going to bring it down next to your nonmetal. So I had lithium, and then I have selenium, and I'm saying I'm going to bring the 1 down next to selenium. So I've taken the 1 and brought it down. The second thing I need to do is take the charge from my selenium, which was -2. I'm going to bring that down and put it next to my lithium. So over here I'm going to write Li2. So this is a crisscross method. That is where those numbers are coming from. And again, notice I'm not writing charges down in my formula. I've taken the charges, now I'm writing the number of each element. The one thing I want to do here is this 1 next to the selenium. I don't need to write a 1 here. It's kind of like when we were doing math. If I said, you know, like x plus 2, I know that the x, because I've written an x there, I don't need to write a 1 in front of the x. As soon as I write the x as a variable, I know there's 1 there. That's the same thing as elements. So if I've written the symbol SE, I know I have at least one of them. So if I get rid of the 1 back here, that's what I'm going to do, I know because I have SE there, I have at least 1. If I had more than 1, I'd write a 2. If I had more than 2, I'd write a 3, or a 4, or whatever I had. But in this case, there's only 1, so I'm just going to get rid of it and just write Li2 SE. And again, this isn't Li minus 2, it's just Li2. Because when I write the formula, I'm just writing the ratio of elements. All right, the next example is calcium and arsenic. So calcium Ca plus 2, arsenic's As minus 3. I'm going to rewrite both elements, Ca, As, and what I'm going to do is crisscross my charges. I'm going to bring the 3 down from the arsenic, and I'm going to write it next to the calcium. So Ca3. I'm going to bring my 2 down from my calcium and put it next to the arsenic. So As2. And that's it. Nothing tricky, nothing other than that, crisscrossing my charges. Ca plus 2, the 2 gets next to the arsenic, the As has a minus 3 charge, and it's going to go next to the calcium. And remember, I'm just balancing the charges. What does this really mean? Well, it means I have 3 calciums. Each calcium had plus 2, Ca plus 2, Ca plus 2, and my arsenics were As minus 3, As minus 3. So in total I have plus 6 charge, and minus 3 times 2, or 2, is minus 6. These things balance out, gives me 0. That's what I always want, is to end up with 0. So that's what each of these questions is doing. You're trying to balance your negative and positive charges. The next example, hafnium. Let's find the symbol for hafnium. I believe it is HF. Hafnium. See if I can find it here. See if you can find it. Hafnium we don't use a lot. All of a sudden I regret erasing the charge. Hafnium, it's element 72. It is HF. Element 72, it's kind of, it's in the fourth column, down near the bottom. And hafnium is one of these funny ones. It has a charge of plus 4. Then the nonmetal is, in this case, sulfur, which is S. And sulfur is element number 16, has a charge of minus 2. All right, so I rewrite both of my elements over here to make my formula, HF and S. One thing that I haven't mentioned that I just kind of assume, but I shouldn't assume, is that when we are writing elements down, it's extremely important that the first letter is capitalized and then the next letter is lowercase. Why is it important? Because if I wrote HFS, H is hydrogen, F is fluorine, S is sulfur, which is different than if I had written HFS. Little letter does not denote an element. HF is hafnium and S is sulfur, which is different than that. So it's really important that if you were writing down the elemental symbols, if there's a lowercase letter, you make sure to write a lowercase letter. It doesn't really happen that often where students mix it up, but every once in a while I see it, and it's important to write them as you see them. All right. This is why the crisscross method doesn't work. So we're going to make the mistake and then we'll go back and fix it. The S from the sulfur is going to come down. So that -2 is going to be written down here. And then the 4 from the hafnium is going to come down. I'm going to write it next to the sulfur. So HF2S4, crisscrossing my charges. Now, if I think back to what this really means, I have hafnium, which has a charge of +4, and I have sulfur, which has a charge of -2. Now, if I just wanted to balance my charges, I would only need 2 sulfurs to balance out my charge of -4. So I have a +4 and a -4. So I only need 1 hafnium and 2 sulfurs. But when I crisscross, I get a 2 and a 4. And that's kind of a problem because I only need 2 sulfurs to 1 hafnium. If I crisscross, I'm going to get it wrong. So this is why crisscrossing only works 95% of the time. What I essentially need to do at this point is, you want to think about it as simplifying, you can. If I end up with a 2 and a 4, I can write these as lowest terms. So if I simplify this now, I'm going to have HFS. What's common to 2 and 4? Well, 2 goes into 2 once, but I don't need to write it in, and 2 goes into 4 twice. So HFS2 is going to be the simplified version of that same thing. So that's really, really important, and this is why crisscross method doesn't always work. Most of the time it does. Aluminum, Al, +3, element 13. Nitrogen is N, -3, element number 7. Again, this is going to be another example of why the crisscross method doesn't work. If this is -3 and +3, if I crisscross, I'm going to get Al3N3. I don't really need 3 aluminums to cancel out with my 3 nitrogens. They each have a charge that's opposite to one another. So if I just wanted these to balance, I would simply just need to write in 1s next to each of these things. 1 aluminum balances out my 1 nitrogen. One has a charge of +3, the other is -3. So instead of writing it as Al(N) with 1s next to them, I just lose the 1s altogether and write it as Al(N). I don't need the 1s. As soon as I write it like that, I know what's there. All right. What I'm going to do is I'm going to leave you there, and because I did your learning guide for you, at least one question, in the course, there was some extra practice. I asked you guys to download this. So this is, should have done it perhaps a little bit slower. In the course, naming extra practice, down here, this guy, naming extra practice. I asked you guys to download it, and there was a bunch of examples in there. So if we open up Naming Extra Practice, we did the Lewis dot stuff already and the Bohr model stuff already. And the, I guess, fourth page of this, name and write the formula for the following monovalent ionic compounds. So starting at this page, zinc-chromium and oxygen, hafnium, or sorry, barium and sulfur, cesium, phosphorus, nitrogen, magnesium. You should be able to do the formulas now for these. So for next day, I would love it if you wrote down the formulas for this page on the extra practice sheet. Next day we'll go through it together. I believe there are 6 questions there. So that's what I'd like you to do. In addition to that, because it is the end of term coming up, I believe the end of term is officially the 19th, which is next Wednesday. But we're going to cut off marks on Friday, just so we can get everything graded and organized. What I would also like you to do is, in the course, there's a quiz. It's 7 questions, and it's right here, 4.1 quiz. It's just 7 questions about protons, neutrons, just stuff from 4.1. So protons, neutrons, electrons stuff. Where do the protons live? Where do the electrons live? If your atomic number is 7, what element are you? How many electrons do you have? Difference between an atom and an ion. So all the stuff we talked about up to the beginning of today's class. 7 questions. I promise you it'll only take you maybe like 5 minutes to do. And that'll be the last mark for this unit, this term. So 4.1 quiz is here. It needs to be done by Friday. You should be able to do it today though. So that's kind of what I'd like you guys to do for next day. 4.1 quiz, extra practice, the 4th page, writing down the formulas. We'll start with naming next day. It's super easy. You guys will fly through it. But the naming's super duper easy. And that's kind of where we're at. Does anybody have any questions before we sign off for the day? Again, we have class on Thursday. And we'll just carry on from where we've left off today. All right, please do that quiz. I'd do it right now. You guys know the stuff already. I promise you, you learned it in grade 9, or you were supposed to learn it in grade 9. It's all stuff you've seen before. So do that quiz, and then that'll be the last mark for the term. So your mark will be finalized. Should be nothing else, assuming you're caught up. That's it for now. I will see you guys on Thursday morning, bright and early. Have a great afternoon. Thanks.